Good morning, N.A.S students. How are you all? I hope everybody is safe and sound. I miss you all, guys. Today we will be discussing the initial concentrations. Okay, initial concentrations of solutions. A reaction system could be made up by mixing different solutions together. Each solution in the reaction system has its own molar concentration C and volume. Let us consider that we have a reaction system that is made up of two solutions A and B. Solution A has a volume V1 of 50 milliliters and molar concentration C1 of 0.2 mole per liter. And solution B of V2 equals to 50 milliliters and C2 molar concentration 0.4 mole per liter. Number one, we need to calculate the initial concentrations of A and B in the reaction system. Number two, we need to determine the number of moles of A and B that are found in a volume equals to 25 milliliters of the reaction system. Now, ladies and gentlemen, when I say reaction system consists of the reactants that react together in order to produce the products. Now, since we're talking about the aqueous solutions, the reaction systems that we deal with in this section are simply systems that are made up of solutions mixed together as reactants to carry out a certain chemical reaction. Now let's look at the solution of the application on the previous slide. They asked us to calculate the initial concentration of A and B. We put a bracket and we put A inside the bracket and 0 on the outside. The bracket indicates the concentration and the small 0 written outside on the right side is simply to indicate the initial state. So what is the initial concentration of solution A in the reaction system? We put C1 V1 divided by V total. The C1 for A is 0.2 and its volume is 50, and the reason why I placed divided by 100 is because the total volume of the reaction system is 100, simply because V1 plus V2 equals to 100. The answer comes out to be 0.1 mole per liter. Now students ask me, why didn't you convert the milliliters into liters? You can do this, but it's a step that someone can simply avoid doing. Here's the reason for that. If you place 0.2 mole per liter times 50 milliliter and you divide by 100 milliliter, what happens to the units? The milliliters cancel out and you are simply left with mole per liter. That's why you can, but you don't have to convert the volumes right here into liters, only when it comes to determining or calculating the initial concentrations of solutions in a reaction system. Now, what's the initial concentration of B? Likewise, we put B inside the bracket and we put 0 on the outside. This equals to C2 V2 divided by V total. Plugging in the values, C2 is 0.4, V2 is 50, and of course V total is 100. The answer comes out to be 0.2 mole per liter. This is the answer for part 1 of the application. Now let's discuss the solution or explain the solution of part 2. They said that they took a volume 25 milliliters from the system. Remember that the system has the volume of 100 milliliters. So they took just simply 25 milliliters from this reaction system and they requested that we calculate the number of moles of A and B in the 25 milliliter sample of the reaction system, which happens to have a volume of 100. So we put the number of moles of A equals to the initial concentration of A times the volume expressed in liters. Now the initial concentration of A is 0.1 and we put times 0.025. Now why did I put this number? They want the number of moles in 25 milliliters of the system. So we divided 25 by 1000 in order for the units to cancel out so that we can end up with the moles. So 0.025 comes from dividing in 25 by 1000. It comes out to be 0.025. So 0.1 times 0.025, it's 2.5 times 10 to the power minus 3 moles. Likewise, for the number of moles of B, it is equal to the molar concentration of B, initial molar concentration that is, times the volume of the system, which is 25 milliliters. So you put 0.2 times 0.025, it comes out to be 5 times 10 to the power minus 3 moles. Remember, the number of moles is equal to C times V, only because C, the molar concentration, equals to N divided by V, so N is simply C times V. So the homework, please, on the initial concentrations and more concepts in the book. Pages 35, 36, number 9. Pages 36, 37, number 13. It's a great exercise. Page 38, number 15. Pages 38, 39, number 16. Page 43, number 22. Thank you so much, and God bless.